Hello there, EV here. Welcome to the big low-profile cooler showdown between the CRYORIG C7, the Noctua N9H-L9i and the L9x65. They have some really bad naming schemes. I get the 65, that's 65 millimeters tall, makes sense. Don't get the L9i. Low is L9 is something, I'm not entirely sure. Is that the 9th revision of the low profile cooler? And then we have the I, which is most likely Intel. And then the CRYORIG C7, the C is something and the 7 something. Really generally bad naming schemes all round. We also have the Asus Z170i Pro Gaming Micro or Mini ITX motherboard that's going to be replacing the Gigabyte, what's it called? GAZ170 Gaming 5 something? I don't know. It's a really bad. Naming conventions all around for PC tech parts are absolutely crap. Anyway, so that's going to be replacing that for the Mini ITX test system. Now, what we're going to be doing between these is working out which one of these is following the suit of the Z170i Pro Gaming motherboard as to be the test bench cooler or the test system cooler for all the case reviews to come up within the next at least few years, I hope, depending on whether all the other parts break down and that sort of thing. I also have a saw here just to guarantee that the brown coolers will come off once I finish with them, because if we're going to be ending up using a one of these low profile coolers from Noctua, we're not having that brown fan. We might do something like respray it black or grey or silver, or however we want to go about that. I might leave that up to you guys, whether we go with one or not. So I will be respraying it. Yes, there are inherent issues with spraying a fan which can affect its performance, but if done properly, it shouldn't affect it too badly. And if we go and do that, we will be testing its performance before and testing its performance afterwards, and then doing some all-round observations just to see is it off balance when spinning up the fan and that sort of stuff. So yes, stay tuned for that if you're interested in seeing something like that, and let me know in the comments if you want me to do that anyway. I might do it anyway regardless, even if we do choose the C7. So, without further ado, let's take a look at all of these coolers, check out all their parts. It's going to be a check them all out at the same time kind of video, rather than intricately looking at each one, although we will do as much of an intricate look within a smaller time as possible. As usual, I kind of can't help myself when we're doing these videos. So, thank you very much for checking the video out. I will catch you in a second when we check out all of these lovely coolers. First, let's start off by apologising for the mic bumps in the intro there. There must have been an issue with the pop filter connection to the base or the base connection to the table. Either way, I should really know better. But enough with the apologies, let's check out those coolers. We don't need to test the C7 since it's already been reviewed and tested and has been retested with the new test bench setup, so it's time to figure out what the two Noctua coolers are capable of. First, we'll take a look at the NH-L9i. What initially jumps out is the presentation and excellent looking packaging. In the lid of the box is this ballpoint pen signed installation manual for LGA 115X sockets, meaning this cooler will work with 1151, 1150, 1155 and 1156 sockets, and keep in mind there is an NH-L9A for anyone with an AMD socket. With the internal packaging removed from the box, let's take a look at what we've got. The mold holding everything in place is formed with some sort of dense foam, an excellent choice of quality packaging. Something I didn't take a further look into was the Noctua badge above the cooler. It's essentially an aluminium Noctua badge with some 3M adhesive tape to the back. Just in case you haven't got enough brown in your build, you can add that to finish it off. Up top are 4 mounting screws, and a common move with any Noctua fan is the inclusion of a low noise adapter. This goes between the connections of your fan and your motherboard to physically limit the speed of the fan. An excellent addition to give you the best of both worlds, and an opportunity to go from high to low speed or vice versa in a future build. You may also be able to just make out the small bag of screws below. This allows you to replace the 14mm fan for a 25mm fan. On the other side of the packaging is some Noctua thermal paste. Don't get your hopes up, there's not a lot in there, but I'd say you'd get around 3 to 5 applications, so overall not too bad. And finally, we have the NH-L9i itself and the NF-A9X14 fan in all its beige and brown glory. So let's take a closer look. Just in case you were going to pause the video at any time to count the fins of the cooler, I've done the work for you and we've got a total of 54 fins. Starting with the negative, the sheath from the wire of the fan doesn't quite cover the whole length of the wire, but the majority of the wire is sheathed in some sort of rubbery tubing that's quite easy to kink, as opposed to a braided sleeve which doesn't kink so easily. Something that I feel needs pointing out is that the fan is secured to the cooler by 4 screws, and since the screws threads mesh with a bracket on the cooler to clamp the fan on top, they aren't relying on the plastic of the fan's bracket. This style of mount is going to take much more wear and tear than any bracket that utilises screws that mesh with the plastic frame of the fan itself. As for the cooler and what makes it run, you may notice 2 holes that form tubular channels through all 54 fins on both sides of the cooler. These contain half of the 2 heat pipes, and if you take a closer look at the left side of this shot, you can see that the heat pipes double back through the core of the cooler. If you need to dismantle the cooler for whatever reason, you can remove the fan and then remove the side panels with the 1 screw either side, but there's no maintenance purpose to access behind these side panels. As for the specs of the cooler, by themselves the cooler and fan are only just under the reported 95 by 95mm width and depth. The cooler alone is 24mm tall and the fan is 14mm tall, but remember Noctua do supply screws to fit a 25mm fan. So combined, we're looking at a total unit that's 95mm wide and deep and 37mm tall. As for the fan, the NF-A9X14 is 92mm wide and deep and 14mm thick, which is capable of shifting 57.5 meters cubed per hour. That 57.5 meters cubed per hour doesn't really mean a lot without a comparison, so a premium 120mm fan such as the EVGA F4120ER can shift just over 130 meters cubed per hour. So after doing some really basic maths, this fan is roughly half the volume and has around 45% of the airflow compared to the 120mm fan, so this fan has got some good airflow considering its size. But how does this cooler stack up in the mounting department? Well, right here is all you need to install this cooler. That's it, that is really all you need. So testing this out, I've applied far more thermal paste than is generally necessary, since you really don't know how a mounting mechanism is going to work until it's tested. But, like I've said before, more doesn't negatively impact performance, since the excess just gets squeezed out of the sides. Next, the cooler needs to be held in position, aligning the screw holes with the holes in the motherboard, and then we need to take a short trip round to the other side of the motherboard to fix the cooler to the motherboard with the 4 screws provided. And that's it. Since the cooler is so small, it doesn't need a more elaborate backplate and bracket system to hold it in place. I do want to point out how damn tight the tolerances are on this cooler, but trying to get a great angle of the situation was a little tricky due to those tight tolerances. But by going higher over the motherboard, it allowed me to get a great shot just behind the CPU power connectors. By utilising the art of digitally zooming in post-recording, by squinting past the grain you can catch the seriously tight tolerances between the capacitors and the side plate. It's not far off the thickness of the wire leaving the fan. So with the NH-L9i installed, let's connect it to the CPU fan header, reseat the RAM, and have a little impulsive chat about the L9i. For those of you who just want to see thermals, we're leaving that towards the end so we can cover the thermal results all at once. Anyway, let's have that chat. Just wanted to capture an initial post-installation thought, or a couple of thoughts, on cooler so far. Excellent mounting solution, the best I've seen so far. Very, very simple. Just having the 4 pads align over the holes of the socket, and then just 4 simple screws with knurled edges so you can do most of the work with your thumbs, and you don't have to get a tool with, say, a magnetic tool bit, and having the screw attached to the end of the tool, or having one of those irritating adapters that so many coolers come with. I know the Hyper 212 Evo comes with a Phillips head to hex cross adapter or something like that to be able to install the cooler. So fantastic mounting solution as far as I'm concerned. In terms of how much pressure it applies and some people's opinions on how it applies that mounting pressure to the motherboard, I know having a lot of back plates with then screws attached through that is very popular to be able to spread the load out across the motherboard, but we'll have to see how this turns out in terms of the pressure it's been able to provide to get the distance between the plate of the cooler and the IHS of the CPU as close together as possible, with that thermal paste being as spread thin as possible. So very good mounting solution. In terms of the colour, brown, horrible, still the worst colour I've ever seen from any cooler, and that's pretty much going to be Noctua's thing. I think that's what they're going for. I just don't know why still. I've got it mounted with the fins mounted in a sort of vertical orientation because we've got more room below and above for air to be able to, well, be pushed through and out of the top and bottom than we do to the sides. Clearly we have a heatsink from the motherboard on that side and the RAM on the other side, which is a little bit closer than the heatsink up top and the room at the bottom from the GPU. So that's the way we've gone for it. We're also going to test the other Noctua cooler in the same fashion, so we'll get onto that at some point. This is a different mounting solution to this, so I think it's more complicated, and I think because it's a larger cooler and it's heavier, it is a little more complicated to get that mounting pressure just so. So that's 2 minutes already spent on this, so I'm going to test it and we'll see how it performs, and then we'll get ready to test the other cooler and see where we can compare the CRYORIG C7 already tested, which you can check out in the top right hand corner, and this with the other one. So let's see how it does. Also, I did this segment with the microphone and myself set up as close to the microphone as you can hear me now. I'm talking in my normal voice I would talk to when doing recordings, obviously. So I'm going to throw this from its standard silent curve, which I've got it on at the moment, to full speed. We test all coolers and all case testing is done at full fan speed to get the absolute most out of whatever system we're testing, which means that when you get these results from me, you can work out, well, it's a 6700K 91 watt processor. You can find other information on the processor in terms of what it will do in certain circumstances, but we've got it running at 1.2 volts at 4 gigahertz on this test bench and across all the case tests from now into the future, and we'll be resetting the graphs on those too. But at the moment it's running at about 900 RPM, which seems to be its sort of standard. I think it's its bottom level. I don't think you can go lower than 900 RPM, and that's generally down to the fact that because it's such a thinner fan, it actually needs to run a bit faster to maintain a sort of standard fan speed, or one that would be from a thicker cooler, because you've got a deeper sweep with a thicker cooler. This one's got a much milder sweep. So we're at silent speed, so it's 900 RPM. I'm going to throw it to full speed now, and we will see how it goes. Just before I do that, obviously, because I'm talking over it like an idiot, this means that you can't actually hear the fan speed. So here's the fan speed at silent. At 1000 RPM we are at the moment. I thought clicking the mouse would give you a bit of a reference. And we'll go to full speed now. Okay, so there we go, we're at full speed, which is supposed to be 2500 RPM. Now the max I've seen on this fan is 2454, which just popped out there. But obviously this is plus or minus 10%, as with every fan. But here's a reference as to clicking a mouse. So there we go, that's your reference. Oh, just see 2486 there. So we're hitting basically 2500. So yes, now we can move on to the testing, which will be done at the speed of 2500 at its max speed. Like I mentioned before, we're going to go through both of the coolers and their mounting solutions before we go into the testing and results. Opening up the substantially larger packaging of the NH-L9x65, we first find a box. Opening up that box reveals a lot of different mounting options for various sockets, each with their own instruction manual. This cooler is compatible with all AMD sockets, all LGA 2011 sockets, and all LGA 115X series sockets. Like we mentioned before, that's anything like 1150, 1151, etc. So there's a good chance this cooler is compatible with any socket you're likely to get your hands on. As for the rest of the box, it of course contains everything you'd need to install all supported sockets. Most of it is self-explanatory, but to the left is a crosshead tool that's surprisingly handy, and just above that is the thermal paste and low noise adapter seen in the L9i packaging. As for the main event, the cooler is, I'm gonna call, trapped at the bottom of this box. This was supposed to be a swift shot of removing the cooler from the box like the L9i, but this overly complicated packaging feels like it was made by a completely different company than those that made the L9i's packaging. The cardboard flaps just seem to rub up the wrong way against the cooler inside, and once all of the flaps have been unfolded out, you could be mistaken for thinking this is little Timmy's cardboard kraken. Joking aside, at least it ensures the cooler is safe, and it's cardboard which can be recycled, so overall, it's not that bad. Onto the cooler itself, from a first look, this is just a completely different creature to the L9i. Sort of. In terms of fins, we've got a total of 50 of them, and they all have 2 notches cut out to support 14mm and 25mm fans up top. As for the specs of this cooler, the NH-L9x65 is 95mm wide and deep, same as the L9i, but it's nearly twice as tall standing at 51mm, so this gives us a total height including the fan of 65mm, hence the 65 right in the name of the cooler. The mounting mechanism, or at least part of it, is well hidden embedded into a section of shorter cut fins. This cutout also means that you can use a finger to unhinge the fan retention wire, rather than trying to do this with a nail, which is typical of most examples of this fan retention style. Something we haven't looked at yet is the heat pipe layout. We've got a total of 4 heat pipes that are staggered through the base plate. The staggering means that only one heat pipe type is required to keep the layout uniform and symmetrical, pretty much the definition of good industrial design. So let's get on to installing this cooler to the test bench. What you see laid out here is the contents of the Intel mounting bracket package, as well as the backplate and the Phillips head tool. The only part we don't need for the LGA1151 socket we're mounting to is the set of double-sided bolts, but everything else is coming with us, so here we go. It's good practice to clean the IHS before installing any new cooler. I thought I'd go for a wide spray just to get on someone's nerves. Electronics cleaner, like isopropyl alcohol, is extremely fast drying, so it'll evaporate out of any cracks and crevices it gets itself into. I do this fairly regularly and it's not killed anything yet. First component up is the backplate with pre-installed threaded posts. Just make sure the posts go through the holes in the motherboards and the holes in the backplate line up with the bolts clamping the socket to the back of the motherboard. Next up is the 4 black plastic spacers that go over the posts, which give the right clearance to the brackets which go over the bolts. Then 4 knurled nuts hold the brackets in place and cap off the bolts from the backplate. You can then tighten them up with just your fingers, but if you want to apply a little more pressure, they have screw heads for a reason. Just don't overdo it. This finishes off the mounting platform for the cooler itself. Now we can apply way too much thermal paste again. Notice, like the L9i, we're using Arctic MX2, not the NTH1 that came with the cooler. This is done to eliminate the variables between the coolers to maintain fair test principles. Remember, it's the coolers we're testing, not the thermal paste. As for mounting the cooler, it needs to be held up against the CPU, and then the spring balancing nuts need tightening onto the threaded posts of the brackets behind. I really appreciate that the fan doesn't need removing in order to fix the cooler to the bracket. It doesn't sound like a big deal, but dealing with wire hooks for fans once the cooler is mounted to the motherboard is just a pain, especially if the motherboard is already mounted inside a case. So all that's left to do is to connect the fan to the CPU fan header, replace all the RAM, and get testing. But first, here's that post-installation talk. So we've got the NH-L9x65, I think it's called, on the test bench now. We'll talk about the mounting bracket and then we'll do some sound testing after that, which is just basically you comparing it to my voice and this. I haven't got some decibel meter. I would actually love to get one, but to be honest, we're going to be doing lots of cooler reviews, and by the time I get one of those, we'll have done half of them, and then it's an uncomparable statistic, so forget it. Anyway, we'll just carry on doing this sort of thing. So the bracket, the mounting bracket, way more complicated than I'd like to see. A lot more complicated than the L9i, which is just the cooler itself and a few screws with some nylon washers attached to them, essentially. I prefer that sort of mounting bracket style, but perhaps this one needs a more robust mounting bracket because it's a heavier cooler, and maybe you can only get away with those lighter mounting brackets because they are lighter coolers. The C7 is a little more complicated than the L9i. It just adds a backplate to it. The backplate is quite bulky, to be fair, so it does get in the way of some M.2 slots on some mini ITX motherboards, so watch out for that. But this mounting bracket is way more complicated. You've got all sorts of fiddly bits which you need to make sure they don't fall off when you're attaching stuff. I was a little bit wary that the brackets that went on before you mount the cooler to those brackets, the curved ones at top and bottom, you can rotate them around to rotate the cooler. I was a bit wary that those are going to fall off and hit the graphics card below, which would scratch and damage the surface of the graphics card, and obviously that's something that matters to quite a few people, so be wary that that doesn't happen. You can of course lay the motherboard down flat to make sure that doesn't happen, but accessing it from the back, it gets a little complicated. So more complicated than I'd like to see. Going on to the acoustics now, the noise that it produces. The fan is running comfortably now at 700 RPM. It seems to be as low as I can get it to run on this motherboard, but 700 really is as low as you're going to get it to run without it completely shutting down. So you can listen to it now to see what noise it makes compared to my voice and the mouse. So very quiet, it's obviously not going to annoy you, and this is in an open air test bench, so you put this inside a case and you'll barely hear the thing, especially if you've got some case fans running, but if it's running this low, then you could of course have the case fans running, well, not at all, so that's up to you. Anyway, let's ramp it up to max speed and we'll see what it goes up to. I think max speed is, of course, it's the same fan as the other one. It's 2600 RPM, I think, 2600 RPM. So there we go, we're pretty quickly up to 2500 RPM. It's going to 2581 I just saw there, so it's actually a 2500 RPM maximum, but it's plus or minus 10%, so it's definitely utilising that plus 10% somewhat. It's pretty noisy. It's actually not pretty noisy. You just generally say these things because you over-egg what's actually happening. But here's what it's actually doing in comparison to my voice and the mouse. So yeah, it's not really that noisy, to be honest. I'd actually happily run this at full speed when I'm doing some rendering or anything like that. It's on an open air test bench, so if you put this inside a case, put some case fans around it, the case fans can do, you know, quite a lot of the work for you, so you wouldn't even have to run it this fast. But if you're using a high power processor, then that might be necessary. But talking about running a high power processor, we have a 91 watt 6700K, so let's put it through its paces and see how it turns out in the thermal tests, and then we can compare it to the C7 and the L9i. Before we blast through all the test results, let's get some ground rules set. For all graphs, purple represents cooler height and blue represents maximum CPU temperature from ambient delta T. The graphs are in order of height from left to right, which means as the coolers increase in height, the CPU temperature should decrease, all things being even. And lastly, all testing is performed with Arctic MX2 thermal paste to keep everything as even as possible, and at maximum fan speed, so this is the best possible performance from the cooler right out of the box. You may notice another cooler in the mix, which is the 15-pound Arctic Freezer 11 LP. That was tested alongside the C7 and is within cooler heights we're testing, so it's worth adding in. So starting off gaming benchmarks with Dirt 3, the L9i and C7 are neck and neck, even though the L9i is quite a lot smaller. The L9x65 is a good 4 degrees cooler, certainly expected for its size, and the 11LP being the budget cooler just couldn't keep up with the rest, which is a trend for all graphs to come. Moving on to GTA 5, the L9i seemed to lag a little behind the C7 by a couple of degrees. The 11LP was a couple of degrees hotter than the L9i, and the L9x65 came out on top again, but only just by under 2 degrees cooler than the C7. But at these low temperature tests, every little counts. The Rise of the Tomb Raider results followed near enough the same trend as the GTA 5 results, although the spread was a little tighter. Moving on to synthetic benchmarking, UNIGEN Superposition seemed to favour the smallest cooler, the L9i, and the results seemed to get worse as the cooler's size increased. I've got a couple of theories for results like these, which we'll discuss at the end. UNIGEN Heaven muddied the waters substantially. I had to repeat the test quite a few times to work out a legitimate CPU thermal result for a lot of the coolers. The L9i in particular needed a retest since it was up at 33 degrees previously. Heaven doesn't seem to be a very stable platform for testing CPU thermals, no surprise since it's a graphics-based benchmark. Moving on to something a little more CPU-based, the physics test from 3D Mark Firestrike has the L9i and C7 neck and neck with a delta T of 32.7 degrees, while the Freezer 11LP lags behind again, and the L9x65 takes the lead again with 29.8 degrees delta T. This result is replicated when looking at the temperatures from the graphics test 1 part of the Firestrike benchmark. But saving the biggest result last, the 10-minute Prime 95 small FFTS test has the L9i and C7 neck and neck again, with the 11LP 6 degrees behind them and the L9x65 nearly 5 degrees ahead in the lead. Now, since this is the first sight of the new graphs, new data, and new testing method you can expect to see from this channel for all thermal tests in the future, there are a couple of more options I could have gone through to represent the performance of these coolers. I'll flick through them now, feel free to pause if you want to take a deeper look into them. We could have also shown Dirt Showdown, Hitman, and all parts of the 3D Mark Firestrike test. So we have a total of 9 tests that we can pick and choose from to work out how everything we test performs. I also keep track of frames per second for benchmarks and clock speed for Prime 95, so if there are any differences in performance there, be assured you'll see them. As for these coolers, there was no thermal throttling present or distinctive frames per second drops outside of the typical band of inaccuracy during several runs of a given benchmark. So the results are in, and the undisputed winner in this test anyhow was the NH-L9x65. It's a bigger cooler, it can deal with a higher thermal load, no doubt. But there are a couple of things to discuss. Well, first, in the Prime 95 test, full load for 10 minutes, it only beats the second best, which was the L9i, by a matter of 6 degrees delta T. So one thing to discuss on that is that, okay, this isn't an open-air test bench. You can't expect those thermals to be present if you throw it inside a case or a compact case, something with lesser airflow, a lot lesser airflow than these open test benches. Now, I've seen an increase from certain cases and compare that to this test bench by 20 degrees. You can expect, in some cases, 20 degrees hotter temperatures when you go into a case, so in some circumstances. So that's something for some food for thought. Also, is that in, I think it was UNIGEN Superposition, it was not the winner. It was actually, well, second loser to the 11LP, but the ones which we're actually focusing on today, it was the loser in the Superposition test, I think it was. Might have been Heaven, but I think it was Superposition, where it for some reason, the smallest cooler came out on top. Now, and then the second smallest cooler was the second place, and then the largest cooler was, well, third. Anyway. Why was that the case? I mean, surely the bigger cooler should beat in every single scenario, you would think. But I have a theory as to why it wasn't the winner in that circumstance. Now, I have strapped to a mini ITX motherboard. Now, I'm not letting you know particularly which, or specifically, or not letting you know now what cooler I'm going for. I'll let you know in a second. Now, strapped to this mini ITX board is the C7, the CRYORIG C7. And if you look at the size of the base plate there, you can see it extends all the way through the entirety of the cooler. It pops all the way out to the edge where you can see those curled notches there with the heat pipes going through. Now, the base plate of that is clearly, well, as far as I'm concerned, bigger than the one on the L9x65. You can see that is a smaller plate, it doesn't extend through the entirety of the cooler, and this is the basis as to my theory as to why it didn't perform the best in that case. Now, because it was a lower thermal output and there were lots more little spikes to deal with rather than a full solid load, then it means that if you have a higher thermal mass immediately next to the CPU, then you can offload a lot more thermal energy to that thermal mass, and then the thermal mass can dissipate that over whatever period of time it needs to through the heat pipes. Now, if you've got a smaller thermal mass, you can't do so much of that. It's very much like a cache on a CPU. You can offload lots of little bits of data constantly onto the cache and then retrieve that whenever you need to. But if you have a large amount of data, you need to offload that to something bigger, something that can deal with more of that, such as, say, in the thermal output terminology, that would be a heat pipe. You need to offload into something that can deal with larger, more continuous streams of data. So that's my theory. If you've got lots of little spikes, having a larger base plate is more important, but if you've got a huge load to deal with, you need to have more heat pipes, larger amounts of fins and things like that. So that's the theory there. Anyway, moving on. Which cooler am I going to choose as the one I'm going to run with for the next who knows how long, and who knows how long after that? I might stick with this if I can, potentially, for the next test bench, whenever that is. Probably going to be a few years' time at least. I can't exactly afford some more high-power stuff to put through paces and cases and things like that. That rhymed. Anyway, basically, as far as I'm concerned, it's between the C7 and the L9i, because this is just a lot bigger. It was cool to check out. I'm glad I actually checked it out. Something's rattling. I think I put the fan back on incorrectly. Oh no, it's the bolt. This is no doubt a cool cooler to check out, and I did want to check it out. But it's against the C7 and the L9i. Now, the C7 looks cooler, in my opinion. It looks like a nicer cooler. But it doesn't perform quite as well. In certain circumstances, it performs better and worse in others. So let's just say it performs on par, the same as the L9i. I think we can agree with that somewhat, here or there. I'm going to be choosing the L9i. It's a no-brainer decision. Even though this looks nicer, in my opinion, and it performs pretty much just as well, it's 10mm taller. It's 10mm taller, and you get the same thermal result. Now, obviously the fan is a problem, and we need to deal with that. But let's just say if I got a case and I want to do lots of really tiny case videos because, damn, they're so cool. I really want to get onto those a lot more, or, well, get onto them full stop. Basically, if I have a few cases that can fit a 40mm max CPU cooler, and that would be air cooler or water cooling regardless, then 47mm isn't going to fit, 37mm is. That's just what it comes down to. So the performance is virtually the same, but you can fit into 10mm smaller max CPU cooler cases compared to the C7. So the L9i is going to be traveling with us into the future and be doing all sorts of thermal testing in cases. Now, we're going to have to deal with the fan, of course. We can't leave the fan as brown because that doesn't suit any build. I still don't understand what Noctua's point is. I was actually chatting with my friend Joe about this situation, and we can't get our heads around it. Apart from they want to perhaps make the reputation of their company more in line with just, I don't know, sensible people perhaps, and not crazy kids and gamers and stuff. So I mean, what crazy kid is going to be like, yeah, I want to get a brown fan? No, they're going to want to go with one that's like flashing LEDs and all sorts of stuff like that. So yeah, I think it's a reputation based thing rather than a sort of I don't know, some other metric that they're measuring somehow. Anyway, we're going to have to deal with the colour of the fan. We're going to spray paint it. We're going to test it before and after spray painting to see what it's like spray painting. But the question is, what colour are we spray painting? Now, suggestions in the comments. I want to go with something neutral, between black and white, so greys, things like that. Do we colour the frame separately from the fan, such as, I mean, the CRYORIG C7 has got a black outer frame and it has a white fan in the middle, and I think that's quite a cool look. But it's up to you guys, let me know. Obviously I'm going to make an executive decision. I'm not colouring the thing red or green. It needs to fit in a lot of different cases and suit many different applications, so we're going to go with something quite colour neutral that will fit most cases. Situations, cases, same thing. So that's out of the way. Also, one point I just want to sort of bring up now, because somebody will bring up saying, well, in an ATX case, this is going to look ridiculous because it's such a tiny cooler. Yes, that is the case. It might look a little bit ridiculous. When the color's sorted out, it might look better. But even so, it's going to be very small cooler inside a bigger case. Might look a bit odd. But what I can do in those instances is perhaps get something like the Hyper 212 Evo, stick it in at the end, you know, just while I'm, say, editing and things like that. Once I've done the majority of all the cooling testing, things like that, then I can stick it in at the end, do some B-roll footage with both of them, and you can see what it looks like with a larger cooler and things like that. But I can counter that. But as for testing results, we need something that fits in every case, so that after we've done all the work, or I've done all the work so far, of setting up all the motherboards to output the same voltage and the same frequency, then we're going to be able to test them all together because we have the same cooler and the same system. So that's what we're going for. Anyway, we've got a lot of stuff coming up. Thank you so much for watching. Stuff coming up lately or soon. We're going to be spray painting this fan. We've got the CR280 to complete. We've got the Q300L case to do a review on. We've got the Dust versus Performance video yet to edit and come out. We are soon going to be monetized, hopefully within the next 10 days. Is the perhaps thing that I've got from YouTube. That's the sort of estimated time in the next 10 days. By the end of the month is the suggestion. So thank you much for your patience. Thank you much for your support. Let me know in the comments what you think, and I will catch you in the next video, which will be spray painting that fan. I'll see you then. Thank you very much. Bye bye.